sketch a graph of the following inequalities and find their counterpoints. We will do all this together. Remember, draw the line, shade, draw the next line, shade. Don't draw the line first. That's bad. What's the first x-intercept? Y-intercept. That came out. I'm getting better. Above or below? Yep. 0, 0 is below the line. 0, 0 makes it true. So we're going to shade below the line. Questions. The feasible region is just where your final answer, where all the half planes overlap. It's really not, only if you have those inequalities, let's say x and y greater than equal to 0, do you only consider the first quadrant. So we don't have those here, so our answer could be any quadrant. Is that okay? How's everyone else? Sure. So 0, 0's below the line, right? If we put in 0 in for x, 0 in for y, it'd make it true. So we shade the true side. So since it's below and it made it true, then all points below will make it true. Better? All right. Shading is fun. Order up. X equals -2. What type of line is x equals -2? Don't say straight. Vertical. Here's x equals -2. Solid because it says equal to. Are we shading to the left or to the right of x equals -2? To the right. You could use 0, 0. Again, there's no y value in the inequality, so just ignore the y coordinate. 0, 0 is to the right. 0, 0 makes it true. Shade it to the right. So far we have this triangular region in the center here. Okay. X minus y equals 0. What's the x-intercept? 0. What's the y-intercept? 0. We have a problem. So our finding our intercepts will not work with this line because the x and y-intercept are the same point. Wah, 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 wah. So what we got to do is we have to pick a different number. So let's say y was 2. If y was 2, what do we get for x? Positive 2, because you have to add 2 to both sides. So that means that's the point 2, 2. So all you need is 2 points to graph a line. We already have 0, 0. And now we're going to graph 2, 2. So the reason this is icky is because it happens to go through the origin, which gives us more, oh my gosh, more work, oh geez, more work. What are you going to do? But when we go to do our shading and we pick our test point, we cannot pick the origin because this point, 0, 0, is on the line x minus y equals 0. So pick a point, any point that's clearly not on a properly drawn line. Well, 1 minus 1 is 0, so we can't pick 1, 1. So anytime where the points are the same, or the coordinates are the same, it'll be on this line. So how about 5, 0? So 5, 0 is over here. If I put 5 in for x and 0 in for y, is this true or false? 5 minus 0 greater than. True. So 5, 0 is to the right, below the line. It makes it true, so I'm going to shade below the line. So we're between the purple and blue lines, and we're underneath the black line. What I'm going to do is I'm going to clean this graph up a little bit. On your end, please shade your final region the darkest. So this should be your feasible region. Is this an unbounded or a bounded feasible region? Unbounded. It's unbounded in this case in the negative direction because it's going on forever in the negative direction. How many corner points does it have? 2. What lines intersect to make the corner points? Equal 6, right. So the black and the blue, that wasn't supposed to be the color. I wanted yellow. I guess that's okay. I got it. Hammer time. Good. So the black and the blue make a corner point. What other one? The black and the purple. Why not the blue and the purple? It's not going to touch the feasible region. Good. But now we have to find the intersections. You're going to get 2 examples. You're going to be like, oh, that's right. And then you're going to know it forever. Let's first do the black and the blue. You should have learned 2 ways of solving a system of equations. You have your substitution method and you have your elimination method. Depending on the system will affect which one you should consider. For both methods, they're the same. They're fine for this one. So that everyone's on the same page, I'm only going to review one of them. So if you want to see the other, please watch the video on the interwebs. So what would you like to see, substitution or elimination? Elimination. Elimination, good choice. So in elimination, the whole purpose is to go down from 2 variables to 1 variable. And the way you do that is you multiply one or both equations so that when you add them together, a variable goes away. So this is also called the addition method. Well, notice we don't have to do anything because if we add these equations together, what happens to the y's? They're gone. So let's add them up. So if we add these together, we get 3x plus x makes 4x. The y's are gone, equals 6 plus 0 in most countries, 6. So if 4x equals 6, what does x equal? 6 over 4, and how does that reduce? 3 over 2. Well, that's x. Well, now we have to find y. Once you find 1, you're going to substitute it back into either equation to get your y. Doesn't matter which one you use. Let's use the second one. So instead of x minus y equals 0, we now have 3/2 minus y equals 0. If I add y to both sides, I get 3/2 equals y. Hooray. So what ordered pair is that? What's the x-coordinate? 3/2. What's the y-coordinate? There you go. So this corner point has coordinates 3/2, 3/2. Mike, yeah, that's a fraction. Yeah. Okay, just thought you should know. Thanks. It's going to be okay. Questions? Okay. Now I'm out of room here, so I need to erase that word. Does anyone need more time to write it down? All right. Okay, so next up is the black line, x minus y equals 0, and the purple line, x equals -2. Honestly, for this one, I am going to show you substitution because it's a lot easier. Because x is already solved for. We know x is -2. So let's put a -2 in for the x in the first equation. So instead of x minus y equals 0, we now have -2 minus y equals 0. How are you going to solve for y? Close. Add y to both sides? Sure. Done. Y equals -2. So what ordered pair is this? -2, -2. Is it coincidence that the x and y coordinates are the same? No. Because this line right here, if you added y to both sides, you get x equals y. And that means that all the x values are the same as all the y values. So that's why we got 0, 0, 1, 1, 2, 2 on those points. So it should not be surprising that anything that intersects it also must have that pattern of the same coordinates. So yes, there may be fractions. They may be integers. But what you should not do is base your corner points on the graph. This point here is pretty close to -2, -2. My graph wasn't perfect. But when you have fractions, you have no idea if that point's correct. So you want to definitely use the algebra to make sure that you are at the right point.